So thank you for joining today's DeepSense session. We are with Jason Newport, who is the data manager at DeepSense. Today, we're going to talk about data management for data projects. And at DeepSense, we have worked on a number of different projects so far, and we have some really interesting experiences. So we're going to cover a bunch of topics. And the big thing here is that if there's a topic or question that you have, make sure that you ask, because we might not bring it up thinking proactively about it, because maybe it's just become part of what's human nature to us and we've experienced it many times. We're sharing with you some of the things we've seen, and we're really looking forward to hearing what you have to say. So off you go, Jason.
Okay. Just arrange this. Okay, so heads up, Jennifer. I can't see the chat because my PowerPoint is taking up both screens.
Perfect.
But I can see the Q&A.
Great. So if there's things, then I will flag them.
Okay. All right. So yeah, like Jennifer said, my name is Jason Newport. I'm the data manager for DeepSense. And this talk is generally geared towards hopefully some of your current DeepSense students, or maybe prospective students, or industry partners who have worked with us or may work with us in the future, whether you have data or are collecting data, or really anyone who is interested in data management. So for a little background, who am I? I worked for a little over 6 years as a data analyst in a few brain imaging labs. So this included both collecting data and then also the cleaning process and analyzing of brain images. And I always like to point this out. This is not a stock image of a brain. That's actually my brain, one of the perks of working in brain imaging. And then for a little over 2 years, I've been the data manager here at DeepSense. So essentially for the past 9 years, I've been playing with data. So what I'm going to talk, well, some of data management is very high level. If you're building out a data warehouse, some sort of repository, you're trying to collect and share data, that can be really high level discussions, and I've certainly been part of some of them, but honestly, they can be more philosophical in nature. What I'm going to talk about today is practical data management. So this is very low level. In fact, some of this I hope a lot of you will think it's fairly basic. Some of it is even common sense. But it's something that I've never had anyone teach me this. This is just things I've learned along the way. And this is through experience working with brain imaging data, ocean data here at DeepSense, or even just straight text files, spreadsheets, databases. So we'll start with a little motivation. One of the big things, how much is data worth? Now, if you're a computer science student, your professors have probably supplied you with a data set. Maybe you've gone on the internet to find publicly available data sets. There's lots of them out there. However, you don't get to choose the content. If the information you need isn't in that data set, there's really nothing you can do. But for the companies who are doing this, they know how much it costs to collect data. So back when I was working in brain imaging, it cost around about $500 an hour to use the MRI to scan someone's brain. So pretty typical small 1-year study with 50 subjects could easily cost $25,000. Since I've been working at DeepSense, one of the projects we worked on, this company would rent a boat. They'd have to pay to rent the boat, to fuel the boat, to send their researchers out for 24 hours. And they mounted an echo sounder to the boat and recorded data for 24 hours. So they were easily spending $10,000 for one survey, and they do this about 10 times a year. So they could be spending $100,000 a year for that data set. And that's only one of the data sets they were working with. They were doing other types of data collection. So long story short, data can be very expensive to collect. So once you do, you want to make sure you're making the most of it because data is expensive. So first thing we say and this is generally aimed at people in industry who are collecting data, you want to make sure your data is properly backed up. And so that means in more than one location. I can give an example. We don't want all the backups in the same room, and ideally you want them in more than one site. So one of the offices I worked in, I would get the raw data on a CD that was delivered to me. And once I loaded it on my computer, I put the CD in the desk drawer next to me. My computer was backed up to a RAID box that sat on the desk next to my computer. And every once in a while, we'd put the data on an external hard drive, but it would go on the cabinet behind me. So if any one of these hard drives failed, we had lots of backups. But if something more catastrophic happened, it was in an old building. If the sprinklers went off, if there was a fire or something like that, we could lose all of the data because it was in the same place. So you certainly want to back it up in more than one physical location, ideally at more than one building. So now we're going to talk about data collection. And the first thing I'm going to say is document everything. So one way of doing this is building out a data dictionary. It doesn't need to be anything formal, but anytime you take notes, you want to store them with the data. And the reason you want to do this is because you won't be the only one working with the data. Lots of other people may. You may hire someone new to work with the data. You may partner with DeepSense, and maybe we'll do a project together, and so we'll have a student working with your data. Or you might get a new job. You might leave the company, or maybe you'll just be promoted out of the actual data collection and cleaning. So someone else will have to work with this data, and you will save yourself a big headache if you document everything you're doing. We found that when we get a new data set and we give it to a student, they'll come back with lots of questions on maybe, what a certain variable means, or what units it's recorded in, or something like that. They will have a lot of questions. So if you have the good documentation with it, they'll be able to read it and figure it out exactly what your data is. And so we're going to talk a little bit about metadata now. Generally, it's data about your data. So just an easy example, if you're taking photographs, date, time, and location might be the metadata associated with the photograph. So if this is just your personal photographs, something you're sharing on social media, this will be sufficient metadata. But if you're actually collecting data to use in analysis, right? Like I said, most people will record what, when, and where. But also very important is who, how, and why. So again, if we're talking about photos, we want to know who took it, what camera did they use. And actually, it's very helpful to know why they took it. Just a simple statement of we're collecting this to analyze something in particular. The reason it's good to have this information, especially if there's more than one person collecting the data, two people might be using two different cameras. They may just generally do something different, or they may record the date they took it, but it's in a different format. So it's always good to record as much as you can. And so now I want to talk about file names. And this is something I don't think it's something taught to us, but why do we have a file name? So obviously we want a unique identifier for the file. But we need to go beyond that because you could just call them file 1, file 2, file 3. But that's not really descriptive enough. So what should a file name contain? Really, we want enough information that whoever's looking at the file will understand which file it is. And then a big question is how long should a file name be? I think most of the students here would be too young to remember this, but when I first started working with computers, file names were capped at 8 characters plus 3 for the extension. That was as long as they could be. And luckily that didn't last very long. These days, I believe it's up to about 256 characters can be used in most operating systems. And that will include not just the file name, but the path as well. But that's pretty long. So in fact, a good file name at the max should be maybe 25 to 35 characters. How do we go about choosing a file name? Again, this is something that was never taught to me, but a lot of helpful hints I can come up with. One is don't have spaces in file names. So, you know, for your personal documents on your computer, it doesn't matter if there's a space in the file name, the operating system can handle it. But for data you're analyzing, just don't. It can make a mess. And I would also avoid using special characters in the file name itself. The next thing, this is just personal preference for me. Whenever I read something in all caps, it sounds like someone's yelling at me. So if your file name is in all caps, that's how I'm gonna treat it. Now, sometimes that's okay. If there's a big note that you wanna make in your directory, something very important about the data that's in there, maybe you can, but I would avoid using all caps. And then the next thing is don't have too much metadata in the file name. So one good way of distinguishing if you have lots of different files is to have the date they're captured as part of the file name. And if you start with the date, it's very easy to sort them in chronological order. And further, I would say, you know, there's different formats for if your file name is going to be a little bit longer and you're not having spaces, there's a couple different ways to separate words, either using camel case or underscores or hyphens. Periods aren't the best options because it's also used to denote the difference between the file name and the extension. So if you have extra periods in there, it can sometimes be a pain. And then lowercase only can be ambiguous because there's no distinction where the one word ends and another begins. So if you're going to use one of these formats, I wouldn't mix them. I would pick one, maybe two. And so all of this leads me to my first counter example. Don't do this. This is an actual example of a file I came across, and it is 87 characters long. You can see it's got a space in here. That's why it's on more than one line. It's got an extra space here. It's got an extra period. It's got underscores and hyphens. It's got some parts in camel case. It's got some all caps. It's got metadata in here. It's got the date, even the time down to the second. So in my opinion, this is too long of a file name. It's too much information. though it is accurate information, just looking at this one file name is okay. But when we were looking at this file, this was in a directory with 100 other files, all with a very similar naming convention. And it was just, for just to look at the contents of that directory was just overwhelming. So I would say that's too much information. On the other end of the spectrum, we don't want files named like this. So this is something that happened with us, although I'm exaggerating. We were putting together a proposal, and we had several people pitching in to draft that. So we made a draft proposal, and every time we would make a big change, we'd update the file name. So first it started as a draft, and then it was a final draft. But then, maybe we forgot something, and so we called it, updated final draft. And then maybe we sent it to the boss as an actual proposal, but then we had to go back and make changes. So now it's final proposal, updated final proposal. Or maybe you put the date in as a way of knowing when that was created. But unfortunately, if someone goes and changes it, then the modified date doesn't match the date in the actual document. So so this is sloppy, but this was only one file. But imagine if your whole data set was like this. How can you tell if you go back after some time and you want the latest version? How do you tell based on those names what the latest version is? So again, this is something we don't want to do. So next, we'll talk a little bit about directory structures. So the whole point is we want to make our data easily findable. So one thing we don't want is irrelevant information in the file name. So one example we came up with, we had files that had both a start date and an end date in the file name, but they were all the same duration. So the end date was irrelevant in this case. So that's one way of cutting down useless information. You could move your information from the file name to the directory. So, if you are collecting something every day, you could have maybe divided up into years. So all of 2020's data goes in one directory. And then all the data collected in November goes in a further subdirectory. And by doing this, you now don't need the year and the month in the file name, because that information is contained in the directory. So I'm not going to go into too much detail because it's going to depend very much on what data you're working with. But I will say, think about it ideally first before you start collecting data. But whatever you decide, write it down. Because you want to be consistent across all your data sets to have the same naming convention. And then make sure all copies of your data are in this format. So one thing we'll find is when a student gets a data set, one of the things they might do is move around how the data is stored, start cleaning it, which is good, but then the raw data that in the source location is still going to be maybe arranged in a sloppy way. So it's best if you're collecting data to start in a very good format. And then of course, whatever you decide, you're going to want to apply this to new data. And then of course, train new hires to also follow the same convention. If you do this early on, it'll save you so much headache later on. And of course, periodically, you're going to have to go back to old data and make sure that it's consistent. Right. So far we've talked about a little on data cleaning of just in sort of the file names and how it's stored. But now we're going to actually talk about cleaning the data. And we have found this can take, up to maybe 3/4 of the duration of a project. I know we had one that lasted 4 months, and the first 3 months was spent collecting and cleaning data. And so for a machine learning project, our student was left with 1 month to train the model. So that's not ideal. But having good naming conventions and really organizing your data well to start with is going to reduce this time a lot. And it also allows to do quick automation of tasks. So this is one of the things I enjoy doing is any step in the cleaning process, if it can be automated, that's great. Write a script to do it. And then if your data is organized well, it's really easy to write the script to go through and do all of this work for you. And again, I'll say this often today, but this is going to vary greatly depending on what type of data you have. So some examples of data cleaning would, if you have a grainy image, there might be software you can use to touch that up. You may have audio with static or just unwanted noise. Unfortunately, you'll come across some handwritten documents. So we found occasionally a scientist will collect data and whatever comes off the sensor is going to be in a digital format, but maybe they'll write out their field notes on an actual notebook. So it's not ideal, but sometimes you'll have to convert handwritten data to digital. Other examples of data cleaning is just having data in the wrong columns of a spreadsheet, or maybe different formats. I think the most notable thing I noticed, and this wasn't in terms of data, but this was a piece of software I used. They used, if you wanted to search the log for something, you had to search in a particular date format, but it would output results in a different date format. It still boggles my mind how that's even possible, but yeah. And so another thing we'll notice as we're cleaning the data, we're going to end up with multiple versions of it. So you might think, once you take the raw data and you do some cleaning, you might think, well, we'll just save that as the data and overwrite the raw data. But you almost never want to do that, simply because it's possible you'll make a mistake, or there might have been a problem with the raw data and you need to go back and correct that. So make sure to always keep the raw data as it is. So what I found is each step in the cleaning and processing can yield a new version of the file. So but the question is, if there are 10 steps, do we keep all 10 copies? Right, so you got to kind of find a balance here. And again, it's going to depend on your data and what your pipeline is like. But if you store, each copy and you're having 10 copies of your data now, then your storage needs are going to balloon. You may go from needing, a couple gigabytes for this one data set, but if you're storing 10 copies of it, it's now 20 or 30 gigabytes. So that you don't want to store too much, but at the same time, you don't want to store too little and potentially lose data. So I think a good suggestion is to keep any copy that required manual effort. So some of the steps, like if you have a script that's going to output a copy of the data, and then the next script is going to take that as input and then output another copy, and so on. You don't necessarily need to keep all of those, but anything you do by hand, you're going to want to keep a copy of that. And then again, each new file you create is going to have a new file name. So just make sure you use the one that makes sense. And it may be as simple as just taking the original file name and appending, underscore step 1 or step 2. But again, whatever you choose, 1, make sure that it makes sense, and 2, write it down. So one good thing about this is you will keep learning. Generally, we find when people start collecting data, they're not going to wait until they finish collecting to do something with it. They want to get in and see what's going on. So they start cleaning and processing and analyzing before they're finished collecting. And so they'll learn along the way, and your pipeline may change over time. Now, a good result of this is your latest data set might be really tidy, and that's really good, but your oldest data set won't be. So I said it before, but you should go back and make sure your old data ends up in the same format as what you're currently collecting. Because odds are you're gonna find a new type of analysis to run, and so you'll want to go back to your old data and try that, or someone else will start using the data and they'll need to go back and look at old data. So always helpful to just go back and make sure it's in the same format. So we've talked a lot about just kind of metadata and file names and how to store data. We actually haven't even talked about the contents of the file yet. So, there are questions like, is there a preferred date format? Is there a preferred format for a picture or text? And this isn't really what I wanted to talk about today, so I'll just say, yeah, probably. But we'll leave that for another day. So today I really just wanted to talk about really low-level things that I've personally experienced. And if you avoid, making these mistakes at the beginning, it's going to save you a lot of time and a lot of effort down the road. And I think that's it. So thanks for listening. Do we have any questions? I don't see any yet.
I don't see any either. Does anybody have any questions about data storage, data management, manipulation of it? I think Jason raises a really good point of, the proposals where you've kind of exposed us and shown some of our challenges where we continue to rename files and never delete anything. But I think one of the other big things that we know, to your point, is we have students who will clean and process data, and then they end up with countless versions of it, and then they end up running out of storage space. And so then sometimes you get afraid just to delete things. And I think at some point you just have to make a decision and say, I don't really need this anymore. It looks like we don't have any questions. So unless somebody wants to throw one in.
Oh, I see a couple in the chat.
Oh, what's the difference between data analytics and data science?
Maybe just semantics. I think data science just kind of incorporates every aspect of data. So maybe data analysis is a subset of that. Data science is just kind of a general term for anything you do with data.
And I think too, sometimes it's really organizational dependent, right? Sometimes people will call it data scientist and it has to be someone with a PhD. And then there's other times where, data analysis can be dashboarding and simple Excel spreadsheets. But it could be much deeper than that too. I think it really depends on the organization and what they're trying to get across.
Yeah, I've also been called a data engineer before. I've heard that one. Yeah. I'm seeing a couple in the Q&A now as well.
Great.
So how do you project how much data storage you'll need for your project? It's a difficult one. I think you'll know better after you collect, maybe a small subset of data. You'll know generally how big that format will be, and then you just have to guess based on how many times you're going to do the collection, and then how many steps are in your pipeline, and if you're saving a new copy of it every time. So yeah, you may have to do some math to figure that out.
But I think part of it too is the type of data, right? If you were doing
Yeah.
images, it's very different than if you have a bunch of CSV files. And
Yeah.
I think it's one of those things where, it's a really good question that we should try to pay attention to see what multiplier all of our projects get into, because I think that's something we haven't necessarily quantified. So on average, let's say you started with a terabyte of data, do you end up with 4 terabytes by the time you're finished? And that will be something we will work on. So that's a good takeaway.
Yep.
Have you ever done a data audit? Have you had a data audit done? We haven't had one done, but.
We haven't done anything like that at DeepSense. I did, it may not have been that formal, but I've done something like that in the past where it actually, we somehow discovered a mistake in the data collection. And so we had to go back through the whole data set and try to figure out, did this propagate through the whole step? Do we have to go back from, and redo the analysis from the start? So yeah, I've had to, and I would say it's a pain, but it's even if you don't discover a problem, it's probably something to do on a yearly basis, just as kind of a sanity check, make sure you're still doing things the way you meant to and the way you've documented.
And it's a really good point to think about too, because there's a couple of elements here. Let's say you're working in industry. Sometimes you might actually need to retain certain records for a period of a number of years for confidentiality, for protection, for litigation. There's various reasons you might end up having to keep materials. On the flip side, you end up increasing storage costs. So sometimes, you end up having people have emailed documents and save them on their separate files. And then what's that exponential cost for all the storage and the risk associated with people storing all that data, right?
Yeah.
But it's a good question, because also when you think of your thesis, if someone was doing research, there's increased appetite for you to go and share your data. So once you've completed a project, the world of machine learning especially wants to be able to try to recreate what you've done. So unless it's proprietary or private to a company with trade secrets, you might want to share that. And then you might want to make sure what you're sharing is right. There's another question here about, it's a good question because you touched base on this one, Jason, regarding having multiple storage locations, but one is asking about sharing files on GitHub versus local machines.
So yeah, there's definitely good reason to store something, basically in the cloud where if your local machine crashes, you don't lose your data and multiple people can access it. That's definitely a good thing to do. Another aspect is using it for version control, which may or may not be good for data. For something like software, having version control is very important. But data changes differently than does software. It's not necessarily necessary for data, but
it makes sense. I think it's more having a redundancy, right? And a redundancy people can access. And I think one of the things that we at DeepSense have talked about a lot too is we have shared drives. Like we use 365 and we have things shared because you don't want to have a single point of failure. You don't want your laptop to crash. But then also if something happens to you and someone needs to access your data, you want to make sure that someone can. So there's another question about the fact that you gave that really ugly, legitimate, we experienced file name.
Yep.
Can you give an example of something that's actually a good example? The ideal file name?
That's an excellent question. I don't think I have one right off the top of my head. Some of it may be personal preference too. Like how much data do you need in the file name to understand what it is? If you can read a file name and understand what's in that contents of that file, then that's a good file name. And not just you. If a general user can read it and understand what's in that file, then that's a good file name.
That's a good point.
Yeah.
I think one of the other things too, it really depends on the type of whatever that file is of. So
Yeah.
I think, we've experienced different things where we've done image classification projects. And so maybe if you have codes like an A, B, or C means a certain type of condition and you label it, some of it can be just be finding your classifications. But I think one of the other big things that we've talked about is if you have inconsistencies in those file names and you're trying to run different scripts, how much of a pain in the butt it is to copy and paste and enter all those in. Having something that's quick and easy for you to type or copy is a lot easier than 250 characters.
Yeah.
What's the balance of metadata in the title, but perhaps not enough to search for? So, I mean, I think it's back to, you gave a couple of examples of the date structure, right? There's no right or wrong.
Yeah.
But ideally not one where you're mixing up month and day.
Yeah. I think generally a date structure of year, month, day in that order is good, because it'll always be sorted chronologically. Which, when you're dealing with data, is very helpful.
That's very true.
Yeah.
So I'm going to throw a couple more questions at you. Okay, what would you say is your biggest challenge when you began? Was your biggest challenge when you began your career in data?
Honestly, it was learning about the contents of the data. So when I started working in brain imaging, I didn't know anything about brains at all. When I started working here at DeepSense, I didn't really know about ocean data and the different types of data we dealt with. So it was more trying to gain enough understanding of the subject matter to then make sense of what the data meant, for me anyways.
I think that's fair because I think it goes back with every project that we've done. Unless you're an expert in one specific area, it's becoming an expert more in the mechanisms to clean and process and use and solve data challenges.
Yeah.
Right. I think that's no matter what, if you start a new job, if you change sectors, those data principles are going to remain consistent. It's the data itself that will change. There's value when you can bring both to an organization though. There was a question about our YouTube channel, and I just stuck that in the chat, and I'll also put it in a link when we do post it on YouTube. If I want to dive in data analytics, where should I start? Where should I start from as a beginner? Are there practical skills that are required?
Yeah, certainly. I think some basic computer science skills. As opposed to using a Finder window or something to explore your data, to be able to actually get in on the command line and use some Linux style commands, learning how to use sed and awk and how to script in bash. I've used those extensively whenever I'm dealing with data.
There's another question here that says, when I see two kinds of data formats, should I recommend a unified format?
Yeah, yes. I mean, ideally, yes.
There's a comment there too that says something about would a project manager make a suggestion? And I think this is one of those things that, we've run into some challenges with before where you end up having legacy. So if an organization, kind of like that big, long characters we've had organizations who have had a historical way of doing things. So going back and changing is really hard, right? Because then it's anytime you go and clean and delete data, it's like going and deleting photos off your phone. And now all of a sudden you haven't purged, so you have to suddenly purge again or either rename. So if you're working somewhere and there's a challenge, sometimes it's worth flagging at this point going forward, let's do this instead. You might not want to retroactively go fix, but I think, don't you, Jason, that maybe if you find an improvement, it's always worth making the recommendation.
Yeah. Yeah, definitely.
I'm just looking to see, are there any other questions? I think, it's definitely one of those things that we've learned around data, because we store data, we help people complete machine learning projects using data. So we've experienced people bringing in net new data. Learning about the data has been a challenge, as you said. Cleaning the data has been a challenge. Having lots of versions has been a challenge. But I think one of the things that we have as that lesson, though, Jason, is that every project is the same and they have similar problems. So no one's really unique.
Yeah.
And migrating and moving your data is one issue. Oh, maybe one last question. Do you have any recommendations of migrating and moving data? Any tricks that you've learned for different types of FTP sites, or how some simple ways for you to maybe move larger amounts of data?
I guess it's going to depend where you're moving them to. Certainly, our DeepSense platform doesn't support FTP, so you can't always use a nice software like that. So often it's being familiar again with command line tools. Using rsync is a very good one for copying and archiving data. And then just knowing the different parameters and what you can do with it is really helpful.
Great. So if there are no other questions, I'm just double checking to make sure. Thank you for everyone who tuned in, and we appreciate the questions and engagement. And if you have more questions that anyone wants us to explore in future sessions, please send us an email, messages through our website, through Twitter, through any of our social platforms. And also one last piece is we have another session coming up in 2 weeks. So please be sure to sign up and register and join us and learn more about algorithms. Thank you for joining us. Thank you.
Thank you, everyone.